Today I'm going to represent team number 6 to present project 2, graphing movies and actors. The database we are used here called IMDb, Internet Movie Database. And this database has collected millions of the movies and from all over the world and across more than 100 years. However, if we do the web scraping from the website, first of all, the format issues are not fit for the need of our study. Our primary goal is to do social network study, but the IMDb database designed to do some marketing analysis for the ratings, for the revenues, So later we figure out we downloaded a database and from cargo.com, and the author also used the data from IMDb, but the format is much better, and this database including 1,000 most popular movies made from 2006 to 2016. And first of all, we imported the modules and loaded the data. And then let's overview the data. We can see this data set have the title information, genre, description, director's name, actor's name, year, and the running time, rating, votes, revenue, meta scores. And our primary goal is to identify a 2 large nodes network database. So after we dropped the unused column, we got only titles here and actors here. However, actors here, one rows have many actors. It's difficult for us to manipulate. So we're using a pivot table, making the table become longer. So before we have 14 straight rows, now we have 23,000 rows. And we can see each row only have one actor. But we have a lot of duplicate of the titles in that column. Here we further transform the data by removing the white space. So then we move the data into network X data structure. So we can see this is approval. This transform has been success. And here we see the number of the nodes and ages and the average degrees. And we do a little bit of analysis before visualization. And here we see there are totally 74 connected components in this matrix. And this is a bipartite matrix. And here is an example using Guardian of a Galaxy to test this new matrix. Here we got the degree of 4 for the movie, and this is the age of this movie, and we can see what is the title of the name of the movie, what is one of the actors here. Just like the transformation, we got one row have one actor. And here is the actor Zoe, and in the different movies like Guardians of Galaxy and Star Trek Beyond, Avatar, and etc. So above the test we're showing the transformation is a success. Here we got the list of subgraphs. So that means we have 94 connected components. So each component is one subgraph. and so we make a list. Among them, we got the biggest, largest subgraph, which we have 2,475 nodes, and also the second largest subgraph have 5 nodes, and the third largest subgraph also have 5 nodes. This is the showing the largest subgraph. This is the second and third largest subgraph. This slide showing the involvement of a movie and the actors in the network. We can see this is 2 edges connected. This is 3 edges connected. And this is the further data visualization of the actor and the title of the network. So in here, the graph is quite busy. The blue one is the actor's name, and the red one is the title of the movie. Here is for fun. We got a data visualization of the word cloud on the title words. We can see the most popular words in the titles are man, love, girl, rise, game, and days. Here we can see the distance calculations. First of all, we calculate the radius. The radius means is the distance between one node and other nodes. And here is the center. In here, the center means a movie cover a few genres. And this is the diameter of the network. Diameter is the shortest path between the largest subgraph and the furthest away node in the graph. And here we continue to practice some techniques showing on chapter 3 of the textbook. Degrees here simply capture the number of times and a node appears in the dataset. So Wahlberg is in the most of the top 1,000 movies from 2006 and 2016. Between bad action movies and some surprising hit comedies, this makes sense. Movie would show up here only if they had large cast included in the dataset. And here is the closeness of the centrality. That means a node's ability to reach all other nodes in the network with the fiercest edges. Here is the betweenness centrality. According to our textbook, it's based on the idea that the power residual in the bottleneck between the network. So across the genre, actor like Hugh Jackman, who appears in action films, musicals, and romantic comedies, might be an important connector to different group of actors. Here is the summary of the centrality measurement. So we put the measurement on one table. Here is calculate the eigenvector of the centrality. So here we create a network only contain actors. This is the network. G actor only contains actors, no movie titles. And here we got this network has 1,575 nodes and 5,151 agents, and the average degree is 6.5. Here is the list of some ages we can see. This is Jenny Elfman and Mila Kunis, and those are the relationship with the actors and together in one movie. And here is the click of actors. And here we try to use the island method to see the subgraphs. The island method is to raise the threshold and see how many subgraphs can be existing and showing. And here we got this result. Here we got the threshold is 2. The nodes more than 2 will be in this threshold. Here we can see the actor's name here, and here is numbers of nodes. Here is just one subgraph, and here is the threshold raised to 7, and then we got 420 nodes. Here is just one subgraph, and here we try to visualize the island in the plot. We can see this is the when the threshold is equal to 7, we can see these connections here. It's quite a busy picture. Here is when the threshold reaches to 17, we see less nodes. And here we raise the threshold to 27. We can even less threshold. It's very interesting. We can see one big island here, one small island here. Here is the when we raise the threshold to 37. So the actor's name should appear 37 times in the data set. We only see 4 actors.